the bottom line here is P is log A base 2, Q is log 3 base A, and I don't see any 3's or 2's in here at all, really, do you? No. So, some people decided to use the subtraction rule of logs. Some people went for this straight away. They went log A, 9A squared, minus log 16 base A. Other people went down a divergent path where they took the square out. And what happens if you take a square out there? What could you say that is? Some people decided to call it 3A over 4. Is there anything wrong with the blue path? Anything at all? What's 3A times 3A? What's 4 times 4? So there's nothing wrong currently. Everything's still perfect. Right. What can I change 9A squared into? Can anybody tell me? I can change it to 3A 2B squared. Okay? Quick question for you. Is it possible to move the 2 out to the front from this part here? Yes or no? Why is it not possible? What's the difference between 9A squared and 3A 2B squared? People? Only the A is being squared, which means you can't move it out of the log. And what's the deal with this one here? Everything's being squared so the 2 can move out. Is everybody cool with that? Alrighty. Now, okay, 2 log A 3A. Everybody cool with that? Now, what's the deal with this log 16 here? 16. I could turn that into a 2, couldn't I? How could I do that? I could call it 2 to the power 4, couldn't I? And what could I do with the 4? What can I do with the 4, lads? Bring it to the front. We all good with that? Okay, next part. I don't want log 3A. What do I actually want? Can anybody tell me what would I actually want instead? Look back at the top of the question. It wants 3 on its own, doesn't want 3A. Anybody have a suggestion for separating the two of them out? Would anybody use the multiplication rule of logs or the addition rule? Depends on what way you want to call it. Is it not the same as log 3 base A plus log A base A? See the way the two of them are multiplied by each other? Means you can break them out into addition. For those of you who don't remember this, what can I write log 28 is the same as? Anybody? I could say it's log 7 plus log 4. I could also say it's log 14 plus log 2. Any two numbers that multiply to give you what you're looking for, it will work for. Is that alright? What is log A base A? What's any log by the same base? 1. And what is log 3 base A? Q. And what's log 2 base A? P. What do we get here? 2Q plus 2 minus 4P. Who got that out? Alright, we're going to pause here. I just want to go through one or two little bits about logs as well. Does everybody agree from earlier that, and some of you tried this later on, and I want to nip it in the bud now. Did everybody agree earlier on that log 4 plus log 7 is the same as what? Log 28. Is that cool with you guys? Am I allowed to cancel the logs like that? Does it work? Is 4 plus 7 28? No. Did anybody try that in the exam? Where you just willy-nilly cancelled the logs later on, assuming it behaved like regular maths? If you did, you're not allowed to do that, right? It just doesn't add up. It's a function. The 4 belongs to the log, the 7 belongs to the log. You can't just chop away the logs. Okay? What's the only way you can separate a log from its number? So for argument's sake, imagine I said log 100 equals log 100 base 10 is 2. How do I separate the log from the 100? Anybody know? What's the next line you could write down? 100 equals 10 to the power of 2. That's the only way you can separate those logs. There's no other way. If I had a log 50 divided by log 25, am I allowed to just chop off the logs? No. If that were true, what would be the answer? The answer would be 2. And you can check that in your calculator, can't you? You can say, no bother, log 50, log 25. So are you learning that a lot of regular maths isn't obeyed by logs? Is that alright? That's what makes them so difficult. Okay? Now, let's move on to... Is it here? Next question. Alright, this one. This one's interesting. Okay? And we're going to bring this back down to brass tacks here. Okay? Now, if I have to write this, bring the 1 over the other side is the first smartest thing to do. We all good so far? Nothing I've done, nothing crazy. Okay, next thing. If I said y is smaller than or equal to 1, what values of y would actually work? Would y equals 2 work? Yay or nay? Fails. Y equals 3? Y equals 10? No. Okay. So what you're essentially telling me is that all the y values I choose have to be smaller than 1. Is that okay? Let's keep going. What happens if I choose y equals minus 3? Will that work? Really? What's the modulus of minus 3? Is 3 smaller than 1? No. Damn. What about y equals minus 2? Will that work? Doesn't work, does it? Because the modulus of minus 2 is 2. That won't work either. So what am I stuck with then? What about minus 1? Will that work? It works, doesn't it? So would you agree that I have to be bigger than minus 1, but oddly enough I have to be smaller than 1 as well? Does that make sense? So you could do it two ways. You could say that this thing has to be smaller than 1, or it can be bigger than minus 1. I'm going to do the squaring out method next. Okay? Bring over the 5, what you get? 2x less than or equal to minus 4x less than or equal to minus 2. And what about the other way? 2x greater than or equal to minus 6, x greater than or equal to, was it? Minus 3. Minus 3 has to be smaller than your x value, and your x values have to be smaller than minus 2. Is that okay? All the values in between minus 3 and minus 2 will work. How do you check that? Pick a value, yes, pick a value in between minus 3 and minus 2. Just do it for a sec. Minus 2.5? What happens if I put in minus 2.5? Sorry, what happens if I put in minus 2.5 here? Becomes minus 5. Minus 5 plus 5? Is 0 smaller than 1? Happy days. Second method, what was the method I showed you guys? Tons of you tried it that way. That's not the way I showed you. What did I show you? Square both sides. And what I showed you then was square that. So we're going to square 2x plus 5 by 2x plus 5, and we're going to get 4x squared, what's it, plus 10x plus 10x plus 25 less than or equal to 1. I'll be with you in a sec, Louis, okay? And what's 25 take away 1? 24. What number can I divide in by? Right. I'm going to pause here. So I'll show you in a second, right? What type of function is this? What shape? U. Do I have any idea where it's going at the moment? It could be over here. It could be up here. It could be down here. It could only touch it once. I don't know. So what am I going to figure out next? Where does it hit it? And it hits it at -2 and -3. Okay. Now, when you're doing combined fractions, where you combine both of them together, Louis. So you're looking. You want your values to be smaller than 0, don't you? Which means you want it beneath the y-axis. This means all the values in between 2 and 3. What you're not allowed to do is you're not allowed to reverse the signs. X is your one. What did you write down, Louis? -3. That exactly. Oh, then you should have got 10. You can up yourself and I'll remark it then. So, if you didn't get that, does anybody have any version of that they want to ask me about that I may have marked wrong? Yes?
I put it on a graph.
What?
I put it on like a graph.
1 second. Miss.
Yeah.
Put a cool method for doing it as well. Yeah, time covered. If you have something like this, if you have 4 squared minus 1 squared, sorry, if you have 4 minus 1 equals 3, and you square both sides, and you square it individually like you were attempting to do, it doesn't work. So that'd be 16, take away 1 equals 9. So your system was flawed to begin with, and 2 wrongs doesn't get you the full marks, okay? That's it. Alright. Now, lads, Terry came up with a cool way, actually got him full marks in the end. So, here's what he decided to do. It's not the usual way of doing it, but it was a great little backup. So what he did was, he goes, this is 2x plus 5, less than or equal to 0, or sorry, less than or equal to 1. He goes, completely forgot to do this, lads. I'm going to go to my calculator and I'm going to draw the function. So Terry went in and said, alright, I'm going to draw this absolute value of 2x plus 5, and, sorry, 2x plus 5, and he just goes, whatever, minus 10 to plus 10 somewhere. Okay? And he goes, look, here's my values. So Terry goes in and we'll draw from -3 to 0, okay? Is what I'll do. So he comes in, he goes, no bother, here's my graph, and sorry, it's not perfectly vertical because of the scan, but either way, that's a 1. I'll do every 2. So I want to bust this up. Right, so that's 2, 4, that's -2, that's -4, -6, 2, 4, -2, -4. Terry comes along and goes, okay, I got the point 3,1, -3,1. -3,1 is here. And then he goes, no bother, let's keep going. We got -2,1 as well. Is that alright? And then, what's it, 3,1 and -3,1 and -2,1? -3,1, -2,1, -1, 3, and 0, 5. Right? So you can see that essentially, now there's a point of interest here. We don't really know where it hits the axis, do we? What could Terry do there? He could go back and do a step of, anybody? Huh? You could do a step of 0.5. Got to narrow it up a bit. You could do a step of 0.5. I don't know if you did this. Did you do a step of 0.5, Terry? You just sort of bounced it back up, did you? Instinct. Where is it? Zero's got to be here somewhere. There it is, -2.5. So -2.5 is 0. So he bounced the 0, bounced it back up again, okay? Now here's the interesting part. He knows that he wants it to be smaller than 1, doesn't he? He wants the answer to be smaller than 1. And where is it smaller than 1? This little part there. See the little V? That's where it's smaller than 1. And where does that start? It starts at the value x equals minus 3. And it ends at the value x equals minus 2. Which is the same two answers as above. So that's another good way of doing it. Good job. Alright, let's move on to the next one. Alrighty, question 3. Oh, this is painful. Very painful. Shh. Lads, simple as, you either studied it or you didn't. Louis. You either studied it or you didn't. Okay, what's the substitution for this? It's a learn off. Y equals y squared would be e to the power of x squared, which is, okay, so it's y squared minus 8y plus 15. There's nothing difficult about this. And then after that, solve it, and what do we get? 5 and 3, is it? And for 8 marks, y equals 3 and y equals 5. Is that a suitable answer? You're meant to be solving for x, not for y. So what do you put down now? E to the x equals 5 and e to the y equals 3. You could choose any log you want, but what's a good log to choose? What's log 10 base 10, anybody? 1. What's log e base e? Any log but the same base? 1. Log e is actually ln. So ln e is also 1. You're allowed to choose any log you want. I'll show you that in a second. But preferably you would have chose ln. Now, it's going to be ln e to the power of x equals ln 5. Ln e to the, sorry, that's e to the x as well. Ln e to the x equals 3, ln 3. What happens to the x? It's in power mode, so what happens to the power? And what is x ln e? What's ln e? We already discussed this earlier. 1. So x equals ln 5, which is 1.6, is it? And x equals ln 3. And what's ln 3? 1.09? 8. Alright, gents. What happens if you chose a log that wasn't ln? Let's do that as well. What happens if you chose a log that wasn't ln? So what happens if you chose regular log? What's regular log again? Regular log is just log base 10, isn't it? So, here's what happens. Okay, what happens to the x? Where does it always go? Huh? Yeah. Is log e equal to 1? Yay or nay? You can check it in your calculator, can't you? It's log base 10, so no, that doesn't work. So what's x on its own? Log 5 over log e. And you'll find that log 5 over log e is roughly 1.6. The same answer you got using the other logs, wasn't it? And what's log 3 over log e? Anybody? 1.098. So, even if you use different logs, you still get the same answer. Is that alright? Great. Now, in the case here, if I had log x equals log 5, could I cancel the logs in this case? Could I just say, ba-bam, x is 5? I can, can't I? Now, if I had this, am I allowed to do this? No. Okay? what would I have to do to the other side first? What's log 5 plus log 7? Huh? Log 35, is that correct? Could I cancel the logs now? You're allowed to cancel them when they're exactly the same log and there's only one of them on either side. Next question. If I had log x equals log 35, but then there was like another number after it, like 6, would I be able to cancel them now? Would I be able to do that now? No. Has to be one log on the left and one log on the right, and they're both the same base, then you could cancel them out. Is that okay? Just so you know. Alrighty, let's move on. This one. This one stung a little, lads. Stung. Alrighty. You don't square both sides. There's a specific method you learnt off of this. Who knows the specific method for this question? What was the specific methods that we do every time when there's an x on the bottom? When there's an x in the denominator, Charlie, what do we do every time? Rationalize the denominator. And in English, what does that mean?
Multiply the top by the denominator, bottom by the denominator, and the outside by the denominator squared.
Denominator squared. Multiply top and bottom by the denominator squared. What does this guarantee? When you multiply both sides by a guaranteed squared number, what does it mean? So example is, if 2 is smaller than 3, if I multiply both sides by a positive number, what happens? Like, let's say 5. The inequality is still in the correct direction, isn't it? What happens if I multiplied it by a negative number like -5? What would happen? What would happen? I'd have to switch it, wouldn't I? Now what's the problem with x minus 5? I don't know if it's positive or negative. So I can't just cross multiply it up. I can't just bring it up. So some people did it like this. You brought the 2 up to the 2x minus 3 and you said 4x minus 6. And then the other people, you brought the x minus 5 up to the 3 and you said less than 3 into x minus 5. My problem here is I don't know whether you should switch that or not. Does that make sense? Do you switch the sign or do you not switch the sign? Or do you have to take both answers into consideration? Let's take both answers into consideration. Sometimes you don't. 2 options, isn't there? You switch or you don't switch. Is that alright? So what happens if we do this? Do we get the same answers? It'd be interesting to find out. Just for those of you who went down this route. Bring it over to your side and we get x greater than minus 9. That's correct actually. And what about the other side? Now, crap, is that the same answer, is it? That's x less than? So, that doesn't work, does it? What was the method I taught you guys? So I didn't even bother going through all this. What was the method I asked you guys to do? I asked you to square the denominator on both sides and you'll get your answer, no bother. Let's try that out. What's x minus 5 squared divided by x minus 5? Get rid of the squared. And now, lads, we multiply by the square on both sides and you get 2x minus 3 by x minus 5. Now, see that 2 on the bottom? Is that allowed cross? Is it allowed cross without any worry about switching it around? Let's run a test. 3 is bigger than a half. Agreed? What happens when we bring up the 2? 6 is bigger than 1. It's okay to move it up, isn't it? Okay. So I can move up that 2 if I want. Should be okay. You could just multiply both sides by 2 anyway, couldn't you? As in, 3 is bigger than a half, multiply both sides by 2, 6 is bigger than 1. Makes sense. Alright, so I'm going to bring up that 2. Is everybody happy with that 2 being plunked in there? Alright, and then over this side it's 3 times x minus 5 by x minus 5. We all good so far? Multiply it out. I'm just going to call that 4x minus 6, is that okay? That's where the 2 went. Now we're going to multiply this by this. We're going to get 4x squared minus 20x minus 6x plus 30 less than, multiplied by 3, is it? Okay, bring it all over one side. 4x squared minus 3x squared is 1x squared. Minus 26 plus 30 is plus 4. 30 take away 75 is minus 45. Less than 0. So this is the only method we're able to do this with, really, isn't it? No other methods get us that far. And then what's the answers then? X, what is it? No, wrong way, buddy. 9 minus 5, isn't it? Alright, what shape of function is this? U-shaped. And where does this U-shaped function actually cross the axis? Minus 9 and 5. Do you want it above or below? Above or below, lads? Who knows what I mean when I say above or below? Is it smaller than the x-axis or above the x-axis? It's below. So it starts at minus 9, and minus 9 is smaller than your x values, and your x values in turn are smaller than 5, and that's for full marks right there. Is that alright? We all good? Alright, let's move on. Oop, sorry. Next one. Alrighty. This. So what's the Q value in the first question? What does it tell us the Q value is? 0.3042. What does significant figures mean? If I said 1.06 corrected two significant figures, what answer would you give me? You give me 1.1 because that's 3 significant figures. Okay? If I said 89,512, how many significant figures is that? 5 significant figures. What would be 3 significant figures? What would be 2 significant figures? Everybody remember significant figures? Okay. Now, what you're getting told is the following. You're getting told that e to the power of minus 0.9693t over 5,730 is equal to q, and q is 0.3002. Everybody cool with that? Now, next part. What can I do to both sides? The variable I'm looking for is stuck in the power position. I'm looking for the time. What's the only function that removes variables from the power position? Logarithms. Any log of your choosing. What would be a good log to use? Why would ln be a good log to use? Everybody cool with that? Now, what am I allowed to do with the full power? This full power right here, what can I do with it? Move it all to the front. So what do we get then? Minus 0.693 t over 5730. Oh, sorry, ln e. What is ln e? Does I need to put it in? No. Okay. Now, what's the goal of the question again? Get t on its own. What's preventing the t from being on its own? Alright, so division on the right is what on the left? Multiplication. Multiplication on the left is what on the right? And what's our t value? Just the whole thing. 8, 9, what's it? 15.17. I lost marks, I lost 1 mark. Haven't made a mistake though. 2 significant figures. So what's 2 significant figures? Is that okay with you guys? Any questions, any asks, or anything you didn't understand? Okay. So example is 900, 1 significant figure. 901 is 3 significant figures because the 0 is sandwiched in between them. 910 is actually only 2 significant figures because the 0 is at the end. So I'll give you another example. 85,000 is 2 significant figures. 85,001 is 5 significant figures because the zeros are sandwiched in between. 85,100 is 3 significant figures because the zero is at the end. Now when you go to decimals with significant figures, example will be 0.003. That's 1 significant figure because the zeros in front don't really matter. How many significant figures this time? 3. In between the zeros between 2 normal numbers, so it counts. Okay. And what about this one here? Anybody? 2. And last one? 3. And this one here? 1, 2, 3, 4, 5, 6. Is that okay? All good? Alright. Zeros sandwiched in the middle don't count, but zeros in the extremity don't count as significant figures. But when they're sandwiched in between, they do. So it's whether the zeros in the middle or out to the sides matters. Okay? What's the next question we're on? Oh, this one. Now, oddly enough, a few of you did quite well. Alright? Now, there's a really, really difficult way and a really, really easy way. Okay? The general rule is this. Log a base b is the same as 1 divided by log b base a. You want your base to be a regular number. You have a choice. Do you want your base to be x or your base to be 5? Alright. There's no wrong answer, but one road is significantly more difficult than the other one. So realistically, no offense to you, but you're always going to do the 5. Is that alright? So which one are we going to change? Which one needs to change? Yeah. Now, lads, some of you straight down with the 6. The 6 has nothing to do with it. The 6 just stays where it is. Minds its own business. Says, I have nothing to do with this. Right? What do I change that to? 1 over log x base 5. What do we notice about the 2 of these now? What do you notice? Same thing. Pick a letter. Y. Never pick a letter that's already in use. It makes the examiner feel like you fluked it. And what do we do then? Minus 1y and then bring over the 6. 2 answers. Okay, everybody happy with y equals 3? And, sorry, that's a plus, isn't it? And y equals minus 2. Now what did we say y is again? Y is log x base 5. So what does that mean? Log x base 5 equals 3. What does that mean for x? 5 power 3, which is? And finally, log x base 5. This is one of the most difficult questions in the exam, by the way. And what you get? How many people got above 8 over 10 for that? That's one of the most difficult questions in the exam. If you can get A over 10 in that, you should be able to get A over 10 in everything. Okay? It means you didn't study the other things. Okay? Now, last one was tricky. Last one had a curveball in it. Now you're gonna kick yourself when you see it.
Sir,
Yes?
I didn't ask him, isn't it?
What?
I didn't ask.
On question 7.
Question 6.
Bring it up. If there's an ask for logs, you want to use the log rules that are in your table. You do not do conventional maths. Conventional maths would have you cancel the logs, wouldn't it? Can't use conventional maths. Now, what did the log rules tell you? What did the log rules tell you about log 2 plus log x? What would be a good choice there? Log 2x. What would be a good choice here? Now, I like a scenario where there's log something equals log something else. Why? It's then and only then I can ignore the logs, isn't it? We were over this earlier today. Is there any way to get rid of that 2? Is there any way to send it back in? What could I do? I hope some of you said log y squared. Now I'm at the stage where I can do what? What can I say? Y squared equals? You're always working to have one log on the left and one log on the right. That makes things easy. Right? Now the next one's a doozy. What can I change? Alright, as an example. If 4 to the power of x equals 4 to the power of 3, what can I say about x? X is 3. If 2 to the power of x equals 4 to the power of 3, can I say x equals 3? Why not? Different base numbers, okay? What can I change 4 into? 2 to the power of 2x. And what can I say y equals then? There you go. There's your 2 answers right there. Now, what can we say y squared equals then? Y squared equals y. Everybody agree with that? If y squared equals 2x and y equals 2x, this means y squared equals y. Bring over the 1 and what happens? Or the 1y. Factorize it, what do we get? And then our answer? Y equals 1 and y equals 0. Alright, go back up and have a look. Are logs allowed to be 0? What's log 0? Mad error. 0 is not a valid answer. Okay, how many of us haven't got a clue why log isn't allowed to be 0? Okay, yep. More than that, by the way. Just let you know. Let's run through what logs are one more time. Ready for this? Let's start off with powers of 2. 2 to the power of 2 is 4. 2 to the power of 1 is 2. 2 to the power of 0 is 1. 2 to the power of minus 1 is a half. We okay with that so far? Okay. Now, what you notice about all the answers? They're always going to be positive no matter what, aren't they? Answers will always be positive regardless if the power is positive or negative. So if I ask you what's log 4 base 2, what would you tell me? Log 4 base 2? Which is the answer? How many 2's does it take to make 4? 2. If I ask you what's log a half base 2, what would you tell me the answer is? Minus 1. Exactly, right? Is that right? What are you noticing? These numbers are always positive. 0 is neutral. Okay? And if I did powers of 0, 0 squared, 0, 0 to the power 1, 0, 0 to the power 0, 0 to the power minus 1. Doesn't make sense because there's no power series, is there? That's why we never ever allowed to have a log 0 to any base. Doesn't matter what the base is, you're not allowed to have log 0. It's undefined. Okay? So your calculator will tell you that. Log 0 is a maths error. Any other log of a negative number is a maths error as well. Log of any 0 and below, logs have to be positive numbers. Is everybody cool with that? Logs are always positive numbers. Never negative numbers. Oh, example. You're never going to be asked a negative power series. Look at this. You're never going to be asked minus 2 to the power 2. Minus 2 to the power 1. Logs specifically only work. Logs specifically only work for positive numbers. They don't work for negative numbers. Is that alright? So you can write that in now. There's something to learn off. Logs don't work for negative numbers or neutral. Okay. And finally, we have our 1y value, which is y equals 1. So what does that mean about our x value? 2 times 1? 2. Is that alright with you guys? Alright. Stop there.